Good morning, student. Today we are going to start the important topic is gravitational potential energy. This topic is most important for your coming exam. So let us now start the gravitational potential energy. So first we know what is gravitational potential energy. So gravitational potential energy of a body at a point in a gravitational field of another body is defined as the amount of work done in bringing it from infinity to that point, but condition is that without acceleration. Okay, so when we bring the body from infinity to point P, then acceleration must be 0. Okay, so let us now derive the expression for gravitational potential energy. For this, consider that Earth is a sphere of radius r and mass m. Okay, we have to determine the gravitational potential energy of body of mass m. So we have to bring that body from infinity to point P and calculate the amount of work done. So at any instant, suppose body is at point A. When body is at point A, then that body experiences gravitational force of Earth. That is equal to F equal to gmm upon x square, because the distance of point A from center of the Earth is x. So by definition, gravitational potential energy of body at point P is equal to work done in bringing the body from infinity to point P. Means we have to calculate the work done in bringing the body from infinity to point P. Okay, so suppose that at any instant body is at point A and OA is equal to x, then force on a body is given by F equal g m upon x square. Okay, it is the equation number 1. Now displace the body from A to B through a very small displacement, then a small amount of work done is given by dw equal to F into dx. Okay, so dw equal to g mm upon x square into dx. Here dx and dw is the integral coefficient, so integrating both sides. Integrating both sides. So integration of dw equal to w integration sign g mm upon x square into dx. Now put the limit. Lower limit means from where body is bringing. The body is bringing from infinity to lower limit is infinity, and the final point is point P, whose distance from center of the earth is r, so the upper limit is r, right? So dw equal to gmm is a constant taken outside, integral infinity to r, and this x square when moved to numerator, then it will be x raised to power minus 2 into dx. Now apply the integration formula. W is equal to gmm x raised to the power minus 1 upon minus 1 limit infinity to r, because as we know that integration x raised to the power n dx is equal to x raised to the power n plus 1 upon n plus 1. Here n is equal to minus 2, so n plus 1 means minus 2 plus 1 is equal to x raised to the power minus 1 upon minus 1. This minus 1 taken outside, so w is equal to minus gmm, and this x raised to power minus 1 can be written as 1 upon x, limit infinity to r remains same. So w equal minus gmm. Okay, now substitute the limit upper limit minus sign, then lower limit. So as we know that 1 upon infinity is equal to 0. So W equal to minus gmm upon r. So this work done is stored in a body in form of gravitational potential energy. This work done is stored inside the body in form of gravitational potential energy. Okay, so U equal to minus g mm upon r. So gravitational potential energy of a body is given by U equal to minus g mm upon r. Now discussion of result. Okay, the first point, negative sign of gravitational potential energy shows that potential energy is due to attractive gravitational force exerted by on the body. It means to move the body from infinity to point P, work is performed by gravitational field of the earth. Okay, then second point, when R is equal to the value of gravitational potential energy, that is U equal to 0, because R is in denominator. So when infinity is substituted in denominator, then final value of U will be 0, right? Now move to third point. If a body of mass m is moved from a point at a distance r1 to a point at a distance r2, then change in potential energy of a body is given by delta U equal to integration limit r1 to r2 gmm upon into dx. Okay, now delta U will be gmm 1 upon r1 minus 1 upon r2. If r1 greater than r2, then delta U is negative. Now in fourth part, if a body is moved from the surface of the earth to a point at a height h from the surface of the earth, then r1 equal to capital R and r2 equal to r plus h, then delta U will be gmm. Now substitute the value 1 upon r minus 1 upon r plus h. Okay, now 1 upon r taken as common, so gmm upon r. Here 1 minus r upon r plus h. Okay, so delta U equal to gmm upon r 1 minus r. Now in from this side r again taken as common, 1 plus h upon r. Okay, now this r to r cancel, and this equation can be written as gmm upon r 1 minus, okay, 1 plus h upon r minus 1, because this term when moved to numerator, then sign will change. Okay, now applying the binomial theorem. Okay, so very simple technique to apply the binomial theorem. This power is multiplied to the second term. Okay, so we get U equal to gmm upon r 1 minus 1. When this minus multiplied to second term, then this positive converted into negative h upon r. Okay, now open the bracket, delta U equal to gmm upon r 1 minus 1 plus h upon r. Okay, this 1 to 1 cancel. Now delta u equal to gmm upon r into h upon r. Okay, so gm upon r square, this m written here, this h here. Okay, because since gm upon r square is equal to small g, means acceleration due to gravity, so we get delta u equal to mgh. This is the change in potential energy of body when it moves from the surface of earth to a point at a height h from the surface of the earth. Okay.